All right, guys, this is going to be the next section for trigonometric ratios. This one's going to mainly focus on solving for the angles, okay? So you can see how there's an unknown angle measure there. There's one here. There's one here. So we're going to solve for those. So I'm going to first start off by showing you how to use the calculator, okay, to solve for these angles, okay? So like you see these three trig function ratios right here, and you don't know what A is, okay? You don't know what A is. Unknown, unknown, okay? So we're going to solve for those right here. And the easiest way to do it, all you're going to do is actually just use your calculator, okay? So most of us, like I said last time, are probably using the iPhone calculator. So I'm going to show you off that. If you have an Inspire, it's on there as well. It's closely related. So what you do is you actually use the inverse function, okay, on the calculator to approximate the measure of an angle, okay? And we're going to round to the 10th place on this one. Mostly, I'll probably let you round to the whole number, okay? But as you can see on the face of the iPhone calculator, after you turn it sideways, there's this second button right here that you're going to use. You're going to press that, and that turns these into an inverse, okay? So sine inverse, it has a little exponent of -1. That's what inverse means. And so we're going to use those whenever we solve for an angle. So for instance, for this first one over here, we have cosine of A equals 0.7986. So what you want to punch in the calculator is you want to press cosine inverse of 0.7986 and then just hit equals, okay? So you want to do that. Now, the reason is think about it, and I'm going to show you just once, but we're not going to do this every time. So if I have that function and we want to try to solve for A, we want to get A by itself. Usually it looks like it's cosine times A, but this is not really what it is. This is cosine of angle A. And so what you do to this is you basically kind of like do the inverse of all of that. And when you do the inverse of all of that, it gets rid of that and it gets A by itself, which means just like in algebra, if you did the inverse of this side, you have to do the inverse of the other side. Okay, and so that's it. That's all we're going to do. We're going to just press that in our calculator. Now on the iPhone calculator, remember that we kind of have to press it backwards a little bit. So follow along with me. So I'm going to press 0.7986 first. Okay. Now, maybe let's backtrack, okay? If your iPhone calculator and you cannot see these inverse functions like you see here, see these three inverse functions, if you don't see those, I need you to press that second, okay, where I have the red arrow pointing to. Once you see those, now I want you to press 0.7986 and now press the cosine inverse. And you should get 37.003. Now, since we're only rounding to the 10th place, we do not need to write 37.0 degrees. We can just write 37 degrees. Okay, and so that's it. That's all it takes. So now do the second one. Sine of A equals 0.55. So we're going to press 0.55 in our iPhone, and then we're going to press the sine inverse. And you should get about 33.367 degrees. And if we're rounding to the 10th place, it's 33.4 degrees. Okay. And so all you have to do is make sure you press second so you can see the inverse functions. And that's it. And so this one's a little bit different. It actually has a ratio, which that's the same thing as this, y'all. 12/22. And so we're going to press 12 divided by 22, because that's what like a fraction is. And it should give you the fraction, the decimal answer of 0.545454 repeating. And now we're going to press the inverse 10. And you should get 28.6 degrees. Okay, and that's how you solve for an angle so long as you have one of these trig functions. Okay, so I'm going to show you how to do this on how to solve for angle measures in right triangles, given some information. Okay. Okay, so let's actually do a quick investigation. So we're going to measure each side in centimeters. Okay. Now your measures may not be the same as mine. So if you want to just copy my measures down, that's fine. And we're going to use centimeters. So this one down here looks like it's about 10.5 centimeters. Make sure we're being accurate. Maybe 10.6. Okay, so I'm going to write 10.6 centimeters. Okay, let's try this one over here. And this one looks like about 5.1 centimeters. And so I'm going to use, instead of measuring that last piece, I'm going to use Pythagorean theorem to get it, just so it's kind of a little bit more accurate. So 5.1 squared plus 10.6 squared equals about 138.37. Square root that. So this one's about 11.76. Okay. Okay, so now we have some measures on our right triangle. Now, if you look at the little table, or in step 2, it says, now choose a trig function to solve for each angle. So basically like what we just did on the slide before, we're going to do that here, but with these numbers here. So let's do angle L. So we're going to use this angle L. Let me get a different color. So we're going to use angle L. We're going to solve for that. And you can use whatever trig function you want. So I'm just going to pick tangent. So tangent of angle L equals, now remember tangent is opposite over adjacent. So 10.6 over 5.1. Okay, so that's my trig function. And now look, you'll notice it looks like what we just did. So I'm going to use the inverse function to find the measure of the angle in this column here. Okay, so I'm going to use my inverse function. So I'm going to press second on my iPhone, and I'm going to press 10.6 divided by 5.1 and hit equal. So it turns it into a decimal. So it's about 2.0784. Okay. And then I'm going to hit tangent inverse. So it's about 64.3 degrees. Okay, so 64.3 degrees. Okay, so now let's try it with the other angle. Okay, so let me get a different color. So this one here, so if I'm going to solve for angle N, you can use the same one if you want to. If you want to use tangent again, you can use tangent. If you want to use sine, cosine, it doesn't matter, okay? So I'm going to use sine just to change it. So I'm going to use sine of N equals, remember sine is opposite over hypotenuse, so it's going to be 5.1 over 11.76. So I'm going to put this in my calculator. Remember, I'm going to use that inverse function and put this in my calculator to see what I get for angle N. So I'm going to do 5.1 divided by 11.76, hit equals, so it's about 0.43367, and then hit the inverse sine function. So that's about 25.7 degrees. Okay, so let me just write it in the picture, and you can too. So this one was about 25.7 degrees. The other one was 64.3 degrees. Now, just for kicks, do those add up to 180 degrees? So let's double check that. 64.3 plus 25.7 equals 90. Yep, and 90 plus 90 equals 180. And so now let's, just to show you proof on how these trig functions work, I'm going to get my protractor And you can get yours too. Now remember, your numbers may not match what's on your paper. So when I go right here and I check this out, look at that. That is almost on the money. 25.7 degrees. It's a little less than 26. See how it's right in between? So see, this works. The trig functions work to solve for angle measures. And so this is just a little investigation to show you proof that this does get the angles right. And this one's 64.3 degrees. Make sure it's on there right. Yep, so it's like right there before the 64. Perfect. Or 65, I should say. So we're just going to write down the whole number for these two right here. So this one was about 26 degrees, and then this one was about 64 degrees. Okay, and there you go, using the trig functions to solve for the angle measure. So now how will we see it in a problem? Let's look at these right here. So this first one, it says find the length of any of the sides and round to 3 decimal places, and then find the measures of the angles to the nearest degree. So over here, I'm asked to solve for TS and then find the measure of angle R and S. Well, since I have 2 out of the 3 sides, finding TS is just basically like a review of Pythagorean theorem. I have this side here, 8, which is the hypotenuse. Let's be clear on that, because a lot of people think the hypotenuse always has to go at a slant. This is the hypotenuse because it's across from the 90. So I'm just going to use Pythagorean theorem to find side TS. So 8 squared minus 2 squared equals 60. Okay, and again, I'm just using all calculator, and then you're going to square root that whole thing. So square root. So I get about 7 point, how many, 3 decimal places? 746. 7.746. Okay, so that was just a review. So now finding angle R is what I just taught you. So I'm going to put a little star in angle R. Okay. So to solve for angle R, I'm going to use these nice simple whole numbers, which the 2 is adjacent to the angle, and the 8 is the hypotenuse. Okay, so what uses adjacent and hypotenuse? So you still need to remember that, guys. I'm going to write this down at the bottom. So the TOA, because those are all the trig functions. So adjacent and hypotenuse is cosine. So I'm going to say cosine of angle R equals 2 over 8. Okay, and that's all you need to write down. And so what you're going to punch in your calculator, remember, whenever you're solving for an angle, you have to use the inverse function. Like that. Okay, so let's press that in our calculator. So I'm going to do 2 divided by 8 equals, which is 0.25, and now hit the inverse cosine. And so what are we rounding? Round to the nearest degree. So I get to round to the whole number. This is 75.5, so we're going to go ahead and round to 76. So angle R is 76 degrees. Now, you only need to do this trig function once, okay? I'm not going to do it again because I get to use the 180 rule to figure out what S is. So I know these two, S and R, always add up to 90, so I'm just going to press 90 minus 76 in my calculator, or I'm sure most of y'all can do that in your head. And this is 14 degrees. Okay, and that's it. Let's check out this next one. This one's a little different. I'm going to put a star next to this. I have this piece of information right here. So I need to go ahead and use that. And I can use this to solve for angle P right there. So I'm going to use that right off the bat. So angle P. So I'm going to press 0.781 in my calculator. And make sure you hit the inverse sign. Remember, to get to inverse, you hit the second button. So that's about 51.35. It says I can round to the whole number. So this is 51 degrees. I'm going to use my 180 rule to figure out the other angle. So 90 minus 51 is 39. So I've just solved for both angles. So R is 39 degrees and P is 51 degrees. Okay, so now I have to solve for the other two sides. I cannot use Pythagorean theorem on this one because I only have one side, but I now know the angles, and so now I'm going to use what I learned from the first lesson and use a trig function. So what side should we solve for first? Let's solve for, let me get a different color. Let's solve for RQ first. I'm going to put X just to make it one variable. So if I'm going to use this, and I want to use this angle right here, so I'm going to put a little green dot in this one. That means the X is adjacent to that one. And I'm going to use the 5. The 5 is opposite. And so opposite and adjacent means I am using tangent for RQ. So I'm going to do tangent of 39 degrees equals opposite over adjacent. So the variables on the bottom, so if you remember clearly, if the variable's on the bottom, I'm going to divide. So I'm going to do 5 divided by tangent of 39 degrees, and that's going to give me my side length. So let's go to our calculator. Make sure you do not have the inverse functions on. We're back to normal. So 5 divided by 39 tangent equals, I'm rounding to 3 decimal places, so that's 6.174. 6.174. All right, so there's one side. You can even write it on the picture if you want. Okay, and then to figure out this other side, you can either use trig again, or you can use Pythagorean theorem because you have 2 out of the 3 sides. I'm going to practice with the trig one more time. So this is opposite. I'm solving for the hypotenuse. So what uses opposite and hypotenuse? Sine. So for this one right here, I'm going to do sine of 39 degrees equals opposite over hypotenuse. There's the variable on the bottom again, so I'm going to press 5 divided by sine of 39 degrees. So let's go to our calculator. 5 divided by 39 sine equals, this one is 7.945. Okay, so you do have to use what you previously learned to do some of these problems. Okay, a couple new terms, angle of elevation and angle of depression, okay? So the angle of elevation is, okay, so on this one, angle of elevation is, I'm going to point to it first and then we'll write it in words, okay? So right here, this is going to be your angle of elevation. So go ahead and label the picture first, and then we'll write it in words. So this is an angle formed by a horizontal and the sight line for an object above. Okay, so it's an angle formed by a horizontal and the sight line for an object above. So basically a horizontal, and if you can see, like this guy is looking at the plane above, okay, upwards, this would be your angle of elevation, okay? And so the opposite of that would be angle of depression, okay? So obviously this one right here is your angle of depression. Sometimes also referred to as angle of descent. So if you want to put in parentheses up here, angle of descent and angle of depression mean the same thing. So on this one would be an angle formed by a horizontal. The horizontal is always involved. and the sight line, okay, or line of sight, same thing, for an object, guess, below. So let's imagine the pilot is up here, okay, here would be a horizontal, and his line of sight is looking down at the person. So between that horizontal and that line of sight looking down is your angle of depression, okay? So the reason why I'm going over that is because you're gonna have word problems based off of these as well. Okay, so last one. So we're gonna use angle of elevation and depression to solve each problem, okay? And the best thing that you should do is draw a picture. Okay, so this first one, it says, from the top of a lighthouse, 210 feet high, the angle of depression to a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse, okay? Lighthouse was built at sea level. So we want to draw a picture. Okay, so here's the lighthouse. Okay, and then let's say the water goes straight up to it, and then here's the boat. All right, and so somebody's up here in the lighthouse. Okay, by the way, this is 210 feet. Somebody's in the lighthouse looking down at the boat. And so you can kind of see, guys, the shape of this picture, which is a right triangle. So we just finished working with right triangles. Now it did say that the angle of depression, okay, remember, here's the horizontal. Remember, somebody's up here, and if they're looking down, this is your angle of depression. It's 27 degrees, okay? Find the distance that the boat is from the foot. So I'm going to put a big X here because this is what I'm looking for. Okay. And so if that's 27 degrees, you should be able to solve for this one here, or realize that this is also 27 degrees because these are alternate interior angles. So either one of those works. Okay. So I'm just going to use this 27 because I don't feel like subtracting. And I have the opposite is what I have, and then I have the adjacent is what I am looking for. So what uses opposite and adjacent? Remember, it's always good to write these ratios up at the top, the little acronym. So opposite and adjacent is tangent. I'm going to write tangent of 27 degrees equals opposite, which is 210 feet, over x, which is going to be feet. And I'm going to solve for that. Okay, so the variables on the bottom, so you'll remember what to do. We are going to divide 210 divided by tangent of 27. So 210 divided by tangent of 27. Now remember, we're not solving for an angle, so you don't want to use the inverse. 210 divided by 27, 10 equals. So about 412, what does it say to round to? Hundredth, that's the second decimal, 0.15 feet. I'm going to box my answer. So the boat is about 412.15 feet away. Okay, let's try two more and then we are done. Richard is flying a kite and holding the string 4 feet above the ground with a total length of kite string of 120 feet that is let out. If his horizontal distance from the kite is 55 feet, horizontal distance, keep that in mind, what is the angle of elevation the kite string makes with the ground? Okay, so let's draw a picture. Here is the guy holding the string. The kite is in the air. And what is the angle of elevation the kite string makes with the ground? Okay, so this right here is kind of like the same thing because these would be corresponding angles. So we're looking for this right here, okay? the kite string, he says, is holding us 4 feet above the ground. So that's 4. I don't know if that really has an effect on this, but let's just see. A horizontal distance is 55 feet. Okay. What is the angle of elevation that the kite? Okay, so one more thing. He let out 120 feet of string. So the 4 feet is not going to be involved in our in the trig ratio function. Okay, so we don't really need that. Okay, now, and again, the reason why I say that is you can technically involve this in the problem, but remember the string, if it continues this way right here, this angle is going to be the same as that one because those are corresponding. Okay, so let's go ahead and let me get a different color. Okay, the 55 is adjacent to that. The 120 is the hypotenuse. So what uses adjacent and hypotenuse? Cosine. So I'm going to write cosine of x degrees because I'm looking for that. Remember, that's the angle of elevation. And then it's adjacent 55 over 120. So remember how to solve for the angle. We're going to use the inverse function like this, okay? So we have to press 55. Well, hold on. Let's press second first. Just you can press it on another time, but let's just knock it out at the beginning. So does it say inverse, all the little negative ones? Yes. Okay. So now I'm going to press 55 divided by 120 equals, going to turn it into a decimal. Now press the cosine inverse. So that means x is about, what does it say to round to? Round the angles to the nearest degree. So we can round to the nearest whole number. It's 62.7, so about 63 degrees. Okay, so 62.72 means I'm going to round up. Okay, and so 63 degrees is what the string makes with the ground. All right, last one. An airplane rises vertically 1,000 feet and traveled a distance in air of 1 mile. What is the angle of elevation of the airplane's path? Okay, so here's the airplane up here. I'm not a very good drawer. So there's the airplane, and it said it rises vertically 1,000 feet over and traveled a distance in air of 1 mile. Okay, so when I say traveled a distance in the air of 1 mile, this is the distance that it traveled. What is the angle of elevation? So if I want to draw a vertical line, here we go. Here's my angle of elevation. So remember, the plane is kind of going up into the air like that, and this is 1,000 feet vertically. Vertical goes up and down. Notice I have two different ratios here. Units, mile and feet. So it says, what's the angle of elevation? We have to change to these to the same units. So you can Google how many feet are in a mile, but I believe it's 5,280 feet. So I'm going to just use feet, okay? And then I'm going to solve for that. So what is this to the angle that I'm looking for? This is the opposite, and this is the hypotenuse. So that is the sine function. So sine of x equals opposite 1,000 feet over 5,280 feet. And to solve for x, remember, you need to use the inverse function, okay? And you don't have to write this out every single time, but I want to write it out for the notes so you know what to press. So hit the second function, make sure it's on the inverse. Mine still is from the last problem. And so now I'm going to press 1,000 divided by 5,280. And then I'm going to hit inverse sine. And so x equals about 10.9 degrees, so that's about 11 degrees. So pretty low number, so it's going up at an angle of 11 degrees. That's the angle of elevation. All righty, that is it.